nuclear forces, also known as strong forces or strong nuclear forces, are the fundamental forces that hold the nucleus of an atom together. These forces are responsible for binding the protons and neutrons in the nucleus, which are otherwise electrically repulsive due to their positive charges. The strong nuclear force is one of the four fundamental forces of nature, along with gravity, electromagnetism, and the weak nuclear force. It is the strongest of the four forces, but it has a very short range and only operates at very small distances. It is approximately 100 times stronger than the electromagnetic force and 1038 times stronger than the gravitational force. The strong nuclear force is mediated by particles called gluons, which are the carriers of the force. Unlike the electromagnetic force, which is mediated by photons, gluons carry both color charge and spin, which are the properties that describe the interactions between quarks. Quarks are the building blocks of protons and neutrons, which are the particles that make up the nucleus. The strong nuclear force binds the quarks together to form protons and neutrons, and then binds the protons and neutrons together to form the nucleus. The strong nuclear force operates through two different mechanisms, the residual strong force and the Yukawa force. The residual strong force is responsible for binding protons and neutrons together in the nucleus, while the Yukawa force is responsible for mediating the interaction between nucleons, protons and neutrons, and is caused by the exchange of mesons. The residual strong force is a long-range force that acts between nucleons that are close to each other. It is caused by the exchange of pions, which are mesons that have a mass of about 140 times that of an electron. The residual strong force is responsible for the stability of the nucleus, as well as for the energy released in nuclear reactions. The Yukawa force is a short-range force that acts between nucleons that are very close to each other. It is caused by the exchange of mesons, which are particles that have a mass intermediate between that of the pions and that of the photon. The Yukawa force is responsible for the nuclear binding energy, which is the energy required to break apart the nucleus. The study of nuclear forces is important for understanding the properties of the nucleus, including its stability and the energy released in nuclear reactions. It is also important for the development of nuclear technology, such as nuclear power and nuclear weapons. Nuclear forces are generated in the nucleus by the exchange of particles called mesons between the protons and neutrons that make up the nucleus. The strong nuclear force is mediated by these mesons, which are particles that have a mass intermediate between that of the pions and that of the photon. The strong nuclear force is a fundamental force of nature that binds the protons and neutrons together in the nucleus. This force is generated by the interaction between the quarks that make up the protons and neutrons, and is responsible for the stability of the nucleus. Quarks are held together by the strong nuclear force, which is carried by particles called gluons. The gluons interact with the quarks and bind them together to form protons and neutrons. The residual strong force then acts between the protons and neutrons to hold the nucleus together. The residual strong force is generated by the exchange of pions between the protons and neutrons. Pions are particles that have a mass of about 140 times that of an electron. They are exchanged between the protons and neutrons, creating a force that binds them together. The Yukawa force is another type of nuclear force that is generated by the exchange of mesons between the protons and neutrons. The Yukawa force is a short-range force that acts between nucleons that are very close to each other. It is caused by the exchange of mesons, which are particles that have a mass intermediate between that of the pions and that of the photon. In summary, nuclear forces are generated in the nucleus through the interaction of quarks and the exchange of mesons between protons and neutrons. These forces are responsible for the stability of the nucleus and the energy released in nuclear reactions. The characteristics of nuclear forces, also known as strong forces or strong nuclear forces, are as follows. Strong nuclear forces are the strongest forces in nature. about 100 times stronger than the electromagnetic force and 1038 times stronger than the gravitational force. Short-range, nuclear forces are short-range forces, meaning that they only act over very small distances, typically less than 1 femtometer, 10·15 meters. Non-central, unlike electromagnetic and gravitational forces, which act in a central, radial direction, nuclear forces are non-central forces. This means that the forces act between particles at different angles and directions. Attractive, nuclear forces are attractive forces, meaning that they tend to bring particles together rather than push them apart. This is in contrast to electromagnetic forces, which can be either attractive or repulsive. Saturated, nuclear forces are saturated, which means that they do not get stronger as the distance between particles decreases. Instead, they reach a maximum strength and then level off, independent of charge. Nuclear forces are independent of charge, meaning that they act equally on particles with different charges. This is in contrast to electromagnetic forces, which are stronger between particles with opposite charges. Residual, nuclear forces are residual forces, which means that they are caused by the exchange of particles between particles that are already close to each other. This is in contrast to the Yukawa Force, which is a short-range force that acts between particles that are very close to each other. In summary, nuclear forces are strong, short-range, non-central, attractive forces that are independent of charge and reach a maximum strength before leveling off. They are residual forces, caused by the exchange of particles between particles that are already close to each other. The role of nuclear forces, also known as strong forces, is critical to the stability and behavior of atomic nuclei. Nuclear forces are responsible for the binding energy that holds the protons and neutrons together in the nucleus of an atom, and this binding energy is what provides the stability of the nucleus. The strong nuclear force is responsible for the stability of atomic nuclei and determines the properties of atomic nuclei, such as their mass and binding energy. Without nuclear forces, the protons and neutrons in the nucleus would repel each other due to the electromagnetic force, and the nucleus would disintegrate. Nuclear forces also play a crucial role in nuclear reactions. When a nucleus undergoes a nuclear reaction, such as fission or fusion, nuclear forces play a role in determining the amount of energy that is released or absorbed during the reaction. In fission reactions, nuclear forces are responsible for breaking apart heavy nuclei into smaller fragments, releasing a large amount of energy. In fusion reactions, nuclear forces are responsible for fusing light nuclei together to form heavier nuclei, releasing even more energy. Furthermore, nuclear forces are involved in the creation of heavy elements in the universe. When stars undergo nucleosynthesis, nuclear forces are responsible for the formation of heavy elements. As protons and neutrons combine to form larger nuclei, this process occurs through a series of nuclear reactions, with nuclear forces playing a key role in each step. In summary, the role of nuclear forces is critical in determining the stability and properties of atomic nuclei, as well as in nuclear reactions and the creation of heavy elements in the universe. Without nuclear forces, the universe as we know it would not exist.